You what? It's working? Well, it's not working well, but it's working. What? So far, we ain't really done much in the way of quantum mechanics, have we? Suppose we better change that today, ain't we? So what I decided to do was find the band structure of silicon using a semi-empirical method. Now, I could spend weeks, probably more like months, of my life writing my own code, but luckily I found this paper here online. It's really good. It goes through in detail how the semi-empirical method works, and then if you scroll to the bottom, they were nice enough to even include the code. So we ain't got to waste our lives writing our own. Isn't that nice? I'll leave the links to this paper and the other paper I used in the description. I would recommend giving them a read. Unfortunately, it's in MATLAB. So I'm just going to translate that into Python first, because I don't like MATLAB. Right, so now that we got it in Python, I suppose we better turn it into C, hadn't we? And this is where we ran into a bit of a problem. Now you see that graph there? That took like 7 hours to make, and that's only 8k vectors. We have a look at the Python code here, where you can see it's doing 161k vectors. So it's going to end up taking a really long time. And I reckon if we stick that on a disc and put that in the PlayStation, well, the PlayStation will probably die. So to give us a chance of plotting an actually nice looking graph, we're going to have to make some shortcuts. So instead of using the 10 nearest neighbours, we're going to just use 7. And instead of using 137 plane waves, we're going to use 64. And by only using 64 plane waves, we reduce the Hamiltonian from having 18,769 elements to only having 4,096 elements. So it should be a lot quicker to fill out and a lot quicker to find the eigenvalues for. We've also halved the number of K points. So instead of finding 160 K points, we'll just be looking at 80 K points. So let's run it and see what happens. You see this graph here? Yeah, that only took like 10 hours. Now I was going to put this on a disc and put it in the PlayStation. But, well, basically, I just can't be bothered. So, that's the end of the video.